Well, back from Living History Farms, and I am disappointed to say that nobody threw up in the outhouse challenge. Even more disappointing, I think they actually cleaned the outhouse sometime between last year and this year, because last year it was nasty, and this year it was almost like it was spick and span, so it was pretty ridiculous, but nobody threw up, so it was kind of a wasted trip out there. But for number 3, again, we've got fractions and decimals, and it's a lot easier to do this if you pick which one you want to use, because you can use either one. It doesn't matter. It's personal preference. So since we have so many fractions, I'm just going to make it all fractions. So 4/10, I'm just going to write it exactly what it says. 4/10 is the same thing as 4/10. If you're unsure what it is, you can always check, because if I do 4 divided by 10, I better get 0.4 because they should be the same thing. Alright, now for this we just have to times everything together, and if we just do the variables of the letters first, we find out it's going to be x to the second, y to the third. For the other part, to times fractions together, it's just straight across. So I'm just going to go straight all the way across here. So we've got 5 times 2 would be 10. 10 times 10 is 100. 800, 8,000. So we've got 8,000 up here. And then if we times everything else together, we get 16 8,000ths x to the second power, y to the third power. We should leave it like this. We should be able to reduce a little bit here. So I know if I'm just going to keep cutting it in half, you can probably find bigger numbers that go into it, but I'll just keep cutting it in half. We'd have 8, 4,000. We'd have 4, 2,000. We'd have 2, 1,000. And then we would have 1, 500. So our final answer would be 1/500th x to the second, y to the third. Alright, let's just try this one more time here, but this time we'll use just the decimals if you like working with decimals a little bit better. We've already got 4/10 here. We just need to rewrite these as decimals, which isn't hard to do. I can look at these and I know what they are already, but if you can't do that, you just have to get on a calculator and do top number divided by bottom number. So if I wanted to find 1/5, basically all I would do, there we go, let's see, can we do this? Okay, this isn't going to work. Yeah, well, there we go. So if I do 1 divide 5, not 5 divided by 1, but 1 divide 5, I push 7. 1, that's not going to work. 1 divided by 5, that's just going to be 0.2. So I'll just change this to 0.2. 1/5 is 20%, so it would be 0.2. That's another way to think about it. Half, hopefully everybody knows what a half is. If you don't, 1 divided by 2 is going to be 0.5. 1/10. 1/10 is actually exactly what it sounds. 1/10 is 1/10. And then 4/8. You could do 4 divided by 8 on a calculator, but I know just by looking at it, it is also half, or 0.5. Now we've got all the decimals, and we're timesing them all together. We're still going to have x to the second power, y to the third power. Now I just have to get on my calculator and calculate all the way across, multiplying everything together. 2/10 times 5/10 times 1/10 times 5/10 times 4/10. I should get 0.002, or that would be 2,000ths x to the second power, y to the third power. Now, we can match this up to what we got with the fraction problem. The fraction problem, we got 1/500 x to the second, y to the third. If I take 1 divided by 500 on a calculator, these should be the same thing. I mean, no matter how you do it with the fractions or the decimals, it should be the same thing. So if I do 1 divided by 500, I do in fact get 2,000ths on the calculator, which is the same thing as that. So if you're doing it a decimal way, this would be your answer. If you went with the fraction way, that would be your answer. But just know that no matter which way you do it, those two things are exactly the same.